In the previous video, we saw that there are two systems for measuring angles. Using the system of degree measurement, the total angular measure of a full circle is 360 degrees. Using the system of radian measurement, the total angular measure of a full circle is 2 pi. You will need to become fluent in both systems. We will start this video by doing some practice with those measurements. If going around a full circle gives a measurement of 360 degrees, or 2 pi radians, then going halfway around the circle gives us a measurement of half those quantities. In other words, 180 degrees, or pi radians. If we divide that in half, we will get a quarter of a circle, which will measure 90 degrees, or pi over 2 radians. If we divide this in half again, we get an eighth of a circle, which measures 45 degrees, or pi over 4 radians. If we return to the quarter circle and cut it into thirds, we will have a twelfth of a circle. These measure 30 degrees, or pi over 6 radians. The basic angles of 30 and 45 degrees, or pi over 6 and pi over 4 radians, can be used to construct the most important angles that we will encounter in this class by working our way back around the circle using multiples of these values. If we start with the 30 degree, or pi over 6 angle, we can work our way around the circle to get these measurements. If we start with the 45 degree, or pi over 4 angle, we get these measurements. If we merge these into a single circle, we get this diagram. You will need to know your way around this circle. It will become increasingly important as the semester progresses. Initially, this might seem like a lot of information, but remember that you can build these angles by just starting from the 30 or 45 degree angles. But these aren't the only angles we will encounter. We will need a general method for switching between degrees and radians. We will use the method of conversion factors to accomplish this. Every equality between two quantities can be turned into a conversion factor by creating a fraction from them, and there are two different ways to do this. Because the numerator and the denominator are both the same value, each of these fractions is equivalent to 1, and so we can multiply them without changing the values. The only trick is that we must pick the one that will make the units cancel out correctly. For example, if we're converting 105 degrees to radians, we will pick the conversion factor with degrees in the denominator so that they will cancel out. Or if we're converting 4 pi over 5 radians to degrees, we will need to pick the conversion factor with radians in the denominator. A word of caution regarding conversion factors. It is easy to get in the habit that thinking the value pi must always mean radians, and that the absence of pi must always mean degrees. You must always pay attention to the units. For example, if we're converting 2 radians to degrees, we must still pick the conversion factor with radians in the denominator. It may seem strange to have a pi in your degree measurement, but remember that pi is just a number, and you can always plug this into a calculator to get a decimal approximation.